All right. Hey, everybody. If you hear any distracting noises, that's just my dog Phil. So I wanted to work out a few problems because that was the request of my classes. So I know a few of you wanted me to work out some calorie/joule type of problems. So we're going to go through this one. And I'm going to post these problems also on Moodle so that you'll have extra practice. You can work on these too. All right, so let's do this one, number 2. A peanut butter and jelly sandwich contains 430 calories. A, how many calories are in the sandwich? All right, so we have 430 calories to start off with, but we want lowercase calories. So I'm just going to write that out over here. That's what we want, lowercase calories. But we know that we have 430 uppercase calories, right? That's what we're starting with. This is what we want. This is what we have, right? And so you're going to have your conversion table here. What are you going to use to get from capital calories to lowercase calories? This is like nutritional package calories to your lowercase calories, all right? So that's what? How many lowercase calories are in a calorie? So you want these to cancel out, right? You don't want those units in your answer. So in one uppercase calorie, it's going to cancel out. You have 1,000 lowercase calories. All right, so now you can multiply across and you've got your unit calories, and that gives you what? 430,000. All right, and are my significant figures right? 2, 2. That's correct. All right, B, how many joules are in the sandwich? All right, so this is similar to a problem we worked in class, all right, except they just kind of divided it up. Okay, let's see. You want what? Joules. You want joules, J. All right, so let me give us some more space here. All right, how are we going to work this out? So we already have this many calories, and we know that we have a conversion factor in our best friend from calories to joules. So you look at what you have calories, you want joules. You know that you have a relationship between these two. All right, so I have this. All right, I'm going to add my conversion factor here. You want calories to cancel out. So you're going to have calories on the bottom in the denominator there. And so that'll cancel out. You have 4.184 joules in 1 calorie. So now you can multiply across and you have 180,000,000. All right, so you have 1,800,000 joules. All right, and then you can check your significant figures. All right, you just have 2 here. All right, so with whatever you get on the calculator, with whatever decimal that you're going to get, you're going to be rounding that, and you only want 2 significant figures. So you have 1,800,000. All right, so you're not going to get exactly that with that multiplication, but this is how we get it. We're using significant figures. You're rounding, so don't forget that. All right. Okay. So let's move on to something else. Let's see. Let's work this one. All right. If the beat of a human heart requires 1 joule of energy and a person's heart beats 65 times per minute, how many calories are consumed by a person's heart beating for 1 hour at this rate? All right. So just put yourself in the position of the problem. If you really wanted to know this, how would you solve it? So what are you looking for? You're looking for how many calories, all right? So 1 calorie beating for 1 hour. So, all right, you want calories per hour, all right? Whoops. All right. So, you know you can write out what you have. 65 heartbeats. 65 beats, all right? You're working with minutes per minute. Let's see what else you have, right? You're working with hours. So look at what you have and what types of connections you've got there. So let's start with 65 beats. We know we've got 65 beats, all right, in 1 minute. So we're going to want to cancel out minutes, right? We want our answer in hours. So 60 minutes is 1 hour. All right, so minutes cancel out. You've accounted for that. You have to account for that. Okay, so you know the human heart requires 1 joule of energy. All right, so if you've got 1 joule, all right, 1 joule, that's going to be happening for what beat? For beats. All right, you're going to be canceling out beats. So you put beats in the denominator. So that cancels out over here. All right. And now you're going from joules to calories, right? We just did that. So in 1 calorie, you have 4.184 joules. You want to cancel that out. All right. So you do your math. All right. Put it in your calculator. You can pause it and you're going to write it with the right number of significant figures. You're going to round it to the correct number of significant figures. All right. So what do you get? All right. So all right. So here you're going to be, if you work out your math, you're going to be close to somewhere in the ballpark of 900 something, 900 something lowercase calories. All right. So if you're talking, so with this, we almost have 1 uppercase calorie. All right. So if we're talking about a 24-hour day, so then you have to think 1 of these uppercase calories is going to be multiplied out by by 24 hours. All right, because that's what's happening in 1 hour. So then basically you're going to have 24 calories, or because we're doing one significant figure, it's going to be 20 calories. All right. So that's how you do that. All right. So that's kind of a trickier one. That's a harder one. All right. So let's see what else we could work. Let's balance some equations. All right. All right, so here you're given some steps for balancing chemical equations. All right, so you're going to look at the original equation, decide if it's balanced. All right, then you're going to add coefficients to balance it if it's not balanced. And then you're going to check to see if it's balanced. All right, consider this equation here. All right, so we're going to look in the reactant side and the product side and find how many atoms are present for each of the elements that are in there. All right, so hydrogen on the reactant side, 4. on the product side, 2. Carbon on the reactant side, 1. On the product side, 1. Oxygen on the reactant side, 2. On the product side, 3. All right. So is it balanced? No, it's not balanced. So what are we going to do to fix that? We're going to balance it with the coefficients. All right, so let's make this a little bigger. So how are we going to do this? All right, identify what is going to need to increase on what side. Hydrogen needs to increase on the product side. Carbon is good. Oxygen needs to increase on the reactant side. So you can really pick hydrogen or oxygen. It doesn't matter. All right, you just might have to backtrack more one way or the other. All right, so let's choose oxygen. Let's choose hydrogen. Let's just choose hydrogen. All right. So what are we going to do? We need to increase hydrogen on the product side. So what kind of coefficient are we going to add? We could try to add a 2. If we add a 2 here, then we have 4 hydrogen on this side and we have 4 hydrogen on the other side. All right. Okay. But then we also have to account for this change in oxygen. So now we have 2 oxygen right here. All right. So we have a total of 3 oxygen on this side. All right. So we have 2 oxygen, the 3, 4 now. So we went from 3 to 4 oxygen. All right. So 4 oxygen on this side. So now you're going to have to increase oxygen on the reactant side. All right. So how can you do that? You can do that by adding a coefficient of 2. So now there's 4 on both sides. All right. So let's see. Then we're not going to increase oxygen anymore. All right. Let's see. If we just don't change anything else, all right, because we've corrected our hydrogens and our oxygens. And so if we just put a coefficient of 1, or it's just understood as 1, let's see if we've balanced it out now. All right, hydrogen and the reactants. There are 4 and there are 4. Multiply. Carbon, there's 1 on this side and 1 on the other side. We didn't need to change carbon, right? Oxygen, we have 4 and we have how many? 1, 2, 3, 4. 4 and 4. This is balanced. All right. So you had 1 times 4 on that side, then you had 2. You had 1, 1. All right. You had 2. All right. Here you had 1 plus 2 times 1. All right. This is definitely balanced. All right. Get a good look at that. Okay. So let's see. What else can we look at? We balance another one. Let's pick one. Let's pick this one, A. All right. So for the reactants and the products, we're going to write them out. So for iron, all right, how many? All right, so we have 1 on the reactant side, 1 on the product side. Chlorine, we have 2 on the reactant side, 3 on the product side. All right, so what are we going to do? What do we do about this? All right, so we know that we need to increase chlorine on the reactant side. What do you need to increase? All right, so what if we increase chlorine by 2? All right, so we could do that. If we did that, then we'd have 4 chlorine. And on this other side, we know that we have 3. So that's not going to work out, is it? But if we had 3 chlorine, All right, so if I add a 3 here and I multiply out, then I have 6 chlorine. Sorry for the dog noises. Then I have 6 chlorine on the reactant side, and I have 6 chlorine, and I have, let's see, I have 3 on this side. All right. So let's see. So I have 6 on one side, 3 on the other side. So how am I going to balance that out? So 6 divided by 3 is what? Or 6 divided by 3, you needed 6. So if you do 6 divided by 3, that's going to be 2. All right. So now you have 1 iron on the reactant side and 2 on the product side. You have to look and see, oh, I changed iron. So now what are you going to do? Well, you can just add a 2 coefficient right there in front of iron. So now you have what? You have 2 irons on the reactant side, 2 irons on the product side. You have you have 6 chlorine on the reactant side and 6 chlorine on the product side. All right, so you've balanced this equation. All right, so that's just a little extra help in balancing equation, and there are some more that you can balance on Moodle. All right, so now maybe we'll do some more of those math problems that y'all are interested in doing. All right, let's look at this number 4. All right, for 1.6 activity 3. All right. A prescription for amoxicillin comes in an oral suspension that is 250 milligrams per 5 mils. A patient is prescribed 500 milligrams every 6 hours. How many milliliters of amoxicillin should the patient take per dose? How many mils should they take in a dose? How many teaspoons? All right, so you're going to have to convert to the US system. And how many teaspoons per day? All right, so you want teaspoons per day. All right, well, first we're going to figure out for dose. All right, so we have a couple of problems in here. So let's solve this first part where we want to know how many mils per dose. All right, mils per dose. Okay, so what do? Fine, we know what we want. What do we have? All right, we know that the suspension comes like this, and we know that the patient is prescribed 500 milligrams, all right, every 6 hours. So in a dose, we're starting with 500 milligrams, all right, and so that's in this dose. We're going to want to cancel out milligrams because you don't want your answer in milligrams, right? So you're going to have milligrams on the bottom. What else do you have that comes in milligrams, right? It comes 250 milligrams in that suspension, all right, in 5 mils. And that's perfect, right? You want mils in your answer. So you're going to multiply out, see what you get, and use the correct number of significant figures, all right? You're going to have 10 mils per dose, all right? So there you go. It's simple as that. And keep in mind, if you calculate out significant figures, so you only have one significant figure right here. You only have one significant figure right here. All right, so that's mils per dose. All right, that's what you wanted in your first question. Now you want how many teaspoons per day? All right, so we want teaspoons per day. All right, so what do we have? All right, let's think about this. So how many teaspoons are there in 10 mils? How can we figure that out? All right, so we know that 1 teaspoon is 5 mils. So then how many teaspoons does it take to get to 10 mils? 2, right? 2 teaspoons per dose. So you answered your second question. All right. And so if you have 2 teaspoons per dose, all right, then let's say, y'all aren't used to seeing it like that. All right. So you're going to convert, you're going to say, you know that there's 2 teaspoons in a dose, and how often are you going to be giving that? You're going to be giving 1 dose in 6 hours, right? Because you're wanting to get over to time, you're going to need to cancel out this dose, right? You don't want dose in your answer, you want teaspoons per day, and you got teaspoons right here. So 1 dose is going to be given every 6 hours. All right, now you're going to want to cancel out hours. You want days. So 24 hours in 1 day, and you've got the correct units that you want in your answer. All right, so you multiply it out and you use the correct number of significant figures. That's going to be 8 teaspoons per day. All right, so now I've done an extra one of all of these kinds of problems where you just figure out what is the question. What is the question? Put yourself in the question. What is the question? 2, what do I need? I like to start that way I don't forget the units. All right, what do I need? Then what do I have? What do I have? And you have to then kind of play around with what relationships do I have with these things. All right, how am I going to get things to cancel out? You can think of it that way. How do the pieces connect? And you put it all together. So it does take a little bit of critical thinking. Each one is different. All right. Okay. And I'm going to work that other problem that I worked in class and take a screenshot of that. And I'll post that to Moodle tomorrow too. All right. So now we've done an energy joule type of problem. We've done some balancing of chemical equations. And here we've done one of those math problems. All right. So it really just, the only formula that there is for working it out is to ask yourself these questions. All right. And you can do this in a lot of these math problems. You can put the conversions in any order that you want, as long as you get the right answer. And when you're using a calculator, make sure that you put brackets. All right. You put brackets before you multiply. All right. Put brackets before you multiply. Can't stress that enough. All right. Don't forget those brackets, because then you can end up getting the wrong answer. All right. Thank y'all for listening. I'll post a screenshot of another math problem. But here you go. I hope this helps a little bit.